The Compton-Belkovich Thorium Anomaly is a hotspot on the Moon. It is on the far side of the Moon and was found by a gamma-ray spectrometer in 1998. It is an area of concentrated thorium, a radioactive element. Lunar rock samples from the Apollo missions reveal that most lunar volcanism occurred around 3 to 4 billion years ago, but could have been as recent as 1 billion years ago due to the unknown history of the Moon's far side. Description: the Compton-Belkovich Thorium Anomaly was found in 1998 by the gamma-ray spectrometer instrument on board the Lunar Prospector and subsequently identified as a hotspot, located around 61.1 degrees north, 99.5 degrees east, 61.1, 99.5. The estimated thorium concentration reaches 5.3 micrograms per gram, while the surrounding highland basalts only contain between 0 and 2 micrograms per gram. Compared to the Earth's thorium concentration of 0.06 micrograms per gram, the Compton-Belkovich's is very high. It has unusually high reflectance, identified by a visible imaging study that was carried out later by the Clementine spacecraft in a Clementine Visible Images study. High-resolution images from the Lunar Reconnaissance Orbiter LRO made it possible to analyze the surface features of the Compton-Belkovich Thorium Anomaly in 2011. Location: the anomaly is between the Belkovich crater, which is 214 km wide, and the Compton crater, which is 162 km wide. The region as a whole is 32 km wide and 18 km long. The center of the region is a volcanic complex, 25 km to 35 km across, between the Belkovich and the Compton craters. It is 900 km from the extent of the northeastern Procellarum KIEP terrain. Features: in the center of the elevated region is a depression. This is bounded by scarps and maybe some kind of caldera. Just to the north is a feature called Little Dome, 500 meters in diameter. Further north is an elongated dome, oriented north-south, called Middle Dome. It is 2.5 kilometers long and 0.6 kilometers wide. Both Little Dome and Middle Dome have boulders on top that may be volcanic blocks. Big Dome is further to the north at the edge of the anomaly. It is 2.5 kilometers in diameter with a depression in the top. An extension of the reflective material extends to the southeast from the elevated region by about 7 kilometers. This may be a pyroclastic flow. This more highly reflective area also matches an area that shows a Christiansen feature with shorter wavelength. It reflects more strongly in the 7.1 to 7.5 micrometers range, which indicates quartz or alkali feldspar is the major constituent. Explosive remains also appear scattered to the east for about 300 kilometers, covering an area of 70,000 square kilometers. Volcanic slope. Volcanic features provide information about the composition of the lava that formed the Compton-Belkovich Thorium Anomaly. On average, many volcanoes on the Moon have slopes of lower than 7 degrees. However, the Compton-Belkovich Thorium Anomaly has a slope which reaches 25 degrees at the highest. This suggests that the region was formed by more viscous lava. Composition using infrared reflectance data from Clementine at 750 nanometers and 950 nanometers. The level of iron oxide was determined to be about 3% by mass formation. A direct analysis of Apollo program samples revealed that most lunar volcanism occurred around 3 to 4 billion years ago. However, volcanic activity on the unsampled lunar backside could have occurred around 1 billion years ago. The smoothness of the surface associated with the anomaly indicates that it could possibly have been formed in a more recent event. As the lava cooled, it would have crystallized to produce a silicate structure. Incompatible elements such as thorium would have been excluded from the process and formed thorium-rich pockets in the remaining liquid rock. The eruption associated with the thorium anomaly could have created the elevated features to the west and the low and broad area to the east. The latest possible eruptions of lava would have made domes with steeper slopes, and also would have caused small bulges, as they would barely reach the surface.